Topic 6-1. This can be referenced in the Holt textbook, Chapter 6, Section 2, page 391 through 397, and also Chapter 6, Section 3, page 398 and 4 through 405. You're going to need 2 pieces of patty paper, a triangle, drafting triangle, and a straight edge, a ruler. If your teacher doesn't have a drafting triangle, you can also just ask her for the template, because you could use this template to draw. What we're going to do is we're going to draw a parallelogram on the one piece of this patty paper. So, taking you can actually start with just the drafting ruler. Make sure you fit on the piece of patty paper. It doesn't have to be exactly straight, just anywhere on it. Draw a line, and with that line, line up your right angle to it, so that we are going to create, sliding this up, another line that would be parallel, because it's going to be the same distance all the way across. So we've created 2 parallel lines. You know, you can always show parallel lines like this. There's another, if you wanted to review this again, it's at mathisfun.com, and go to using a drafting triangle to construct parallel lines. Okay, with these 2 parallel lines, take your ruler and turn it sideways. I mean, instead of straight up and down, to make a perpendicular line, we're going to slant these lines. So by slanting them, you don't have to connect end to end, just cross. Don't move it, and cross again. Since the ruler is the same distance across from each other, you've now created a parallelogram. Okay, with your other piece of patty paper, what I want you to do is lay it on top of this one. Doesn't have to be lined up. You can if you want to, but just any direction. Lay that one across that one, and trace this one. You can use a straight edge if you want, but you want to make sure you keep it still. Keep both patty papers the same distance apart. What we're going to do is we're going to show lots of properties of parallelograms using these 2 pieces of paper. Alright, so you have 2 parallelograms. And if you wanted to label these, let's start with this parallelogram. And I'll start here. A, B, C, D. And when you're labeling, anytime you're seeing a label and we say parallelogram A, B, C, D, and you are going to say that it is congruent to another one, you want to name it in the same direction. So let's do Q, R, S, T. Notice I went around in a circle. Q, R, S, T. All right, we're going to show some relationships between these 2 parallelograms. And that is, if I turn this one completely around and lay it on top of this one, notice that B and T are congruent and D and R are congruent. The angles, whether you had it shown this way or turning around, it's congruent. So that proves to us that the sides opposite are congruent to each other. Again, on mathisfun.com, you can go to my little video example of quadrilaterals and kind of look at the theorem that proves that these 2 are congruent. Opposite sides are congruent. So A and C are also congruent to each other. Now, if you lay this on here again, and you know that Q and A are the same exact measures, and so is C and S. If I were to measure this R and slide it up to C, notice it makes a straight line. Let's show that slower. Measure of R, I'm sliding it up to my underneath picture here, shows that it makes a straight line. Consecutive sides, when we talk about consecutive sides, this one and this one, since C and S were the exact same, then B and R were the same, then these two on the same parallelogram, if I add them together, equal 180 degrees, because the pair of angles made a straight angle. Okay, let's go on to some other attributes of parallelograms with your topic page. Let's fill in the definition. A quadrilateral is a closed figure formed by 4 segments intersecting at their endpoints. So notice the first example, write the word quadrilaterals. These are not quadrilaterals. These are not endpoints, because that has two, if I label this and this, that's in the middle. We have no curves in quadrilaterals. So all 3 of those figures in example B are not quadrilaterals. A parallelogram is a quadrilateral in which the opposite sides are parallel. So the parallelogram at the right has 4 vertices, and they are M, N, O, P. M, N, oh, that's funny, P and Q. Key is wrong. P and Q. Notice the denote of 2 arrows show that these 2 lines are parallel, and 1 arrow shows that MQ and NP are parallel. Okay, so again, this wasn't named right. This would be, and if you're going to start with M and go to N, it needs to say MNPQ. Walk around it. Don't say MN and then jump to Q to name it from that way. It's not like reading left to right. It's walking around it to name it. And you can put a little or since it's parallelogram, make it look a little more parallelogram with your little box. The opposite sides of MNPQ are MN and QP and NP and MQ. The opposite angles, and you can actually denote equality here with curve marks for M and Q, and a curve mark with either a line through it or 2 lines through it for M and P to show congruency. That's how the markings would show. The consecutive is ones that walk around it and are next to it. So the ones that's next to N is P, and also next to N is M, and P shares the consecutive angle side with Q, and Q shares a consecutive angle side with N. So when we're talking about consecutive, it's right next to it. And we just did the exercise that showed consecutive angles are also supplementary. So let's go into that. Look at this first example. Using MNPQ, what conjectures can you make about the following? Well, the opposite, let's just do this a little at a time. They are parallel. Remember, denote parallel with 2 strong lines. Look like your parallel lines. By definition, they are congruent because the parallel lines are equidistant. Opposite angles are congruent, and consecutive angles, which we showed a minute ago with our patty paper, or a second ago with the patty paper, are supplementary. And again, they're not just back in further or previous, we noticed that it was same side. If we look back again at this piece, you've got 2 parallel lines cut by a transversal. Remember, we've got the same side interior angles. They didn't jump over my transversal, so they are equal to 180 degrees. Supplementary. equal to 180 degrees. Another definition, when a polygon has more than 3 sides, they have diagonals. So the segments joining opposite vertices in a polygon are the diagonals. So here's all the diagonals you can draw in. And if you name the vertices, the name of it, and opposites and diagonals. Take a minute, pause it, and fill in these values. Please note that when you're naming it, again, you walk around it. Notice how I went A, B, D, C, L, T, O, S, D, S, G, O, and C, T, A, S. We walked around it. The diagonals are the ones that would go across. So to emphasize that these are my diagonals, if you want to highlight it, you're highlighting the movement across the vertices to their opposite vertice. So those yellow highlighted are the diagonals. All right, when we talk about bisecting, you're cutting into 2 equal parts. I want to highlight that, making sure you remember that the bisect means to cut into 2 equal parts, and the diagonals of a parallelogram always bisect each other. So thus, parallelograms have 5 properties. Opposite sides are parallel. Opposite sides are also congruent. Opposite angles are congruent. Consecutive angles bisect each other. And the diagonals bisect each other. So let's look at a couple of examples. Complete the statements regarding the parallelogram below. You've got that AB would be parallel to DC. DA is congruent to C. I got that wrong. B. Should be a B. Angle CDA is congruent to angle ABC. And DE is congruent to BE. This can be shown with a marking to show congruent segments with the midpoint being right there. Okay, another example of this parallelogram, they've drawn one in, is they're showing you consecutive angles, x and 2x minus 3. So consecutive angles, if we were to measure these, you could use your patty paper again and measure that. If I measured this, slid it over to this one, and added d to it, it creates a straight line. Therefore, 180 degrees. So if it's equal to 180 degrees, just solve for x in this one, you get 61. So the measure of angle A would be 61. Okay, last page. In this example, we're going to draw a parallelogram with diagonals that intersect at point A. I'm going to use my template here to draw this parallelogram. Let's draw it around. You can do so also if you'd like to, just to make it a little bit more accurate picture. Alright, so if this is parallelogram X, Y, Z, W, we know that the diagonals created by this are also, they're not congruent to each other. Notice that one's really short and this one's longer. But this is congruent to this segment if the intersection in the middle is point A, and this XA and ZA are also congruent, because you can show all of those congruencies. If we are to say that XA is equal to 3A and ZA is equal to 5M minus 4, we can set those two equal to each other. Therefore, subtract, let's see, -5 on both sides, 5m. That would go away. So we would have a -2m is equal to a -4. Dividing a -2 on both sides would get you to just 2. So if you're just trying to solve for m, then your m is 2. Okay, let's look at another example. For each parallelogram, find the value of x, y, and z. So these are like puzzles. You're having to work through them. But if you know opposite sides are congruent, then we know x is 80 degrees. Y, this is an exterior angle, but it forms a straight line that we know is 180 degrees. So what do we do to find this? Well, those are consecutive, so they have to equal 180. So this angle that we're not even named is therefore the opposite it. Z would also be 100, and so y would be 80, because 80 plus 100 is 180. So just fill in the ones you do know. Z would be 120. And if we were told that this diagonal bisects this, then that's 35, then x would be 35. Oh, wait a minute. No, that's not necessarily true. 120 and 35. 120 plus 35 is going to give you 155. And we know that this whole angle here plus the 120 is supposed to equal 180. So you're going to take the 180 and subtract 155 from that. You actually get 25. So x is 25 degrees. So x is 25 degrees. And therefore y, if these two lines are parallel, you can think of this diagonal as being the transversal, highlighter, cut by transversal. This measurement and this measurement would be the same. So y would also be 35. Okay, if this is a 30-degree angle, then we know that x is also a 30-degree angle. And so if this is 30, and this is 70, this creates a straight line, so this right here would be 110, this angle right there. And so 30 and 110 is 140, so y would make up the other 40 to get to 180. And therefore z would be also 110. Several ways of looking at that. It's a vertical angle to the one we marked here, or it's a supplement with 70 going this way as well as going this way. So study that carefully, back up if you need to. That one's kind of like a puzzle. Start with what you can get through. Okay, last example. Parallelogram WXYZ has these measures, and they look like they've labeled some of them for you. This ZWX, this whole thing right here, and highlight it with a color. That whole thing is angle B. And WXY, so now they're saying this whole thing is D, the measure of D. And that one's different. Find the values of A, B, C, and D. Okay, let's first look at what we know. I think I'd like to pan this one closer. Whoop. maybe a little too close. I think that'd be good enough. Okay, let's look at this one. You've got, let's see if we can figure out B first, because they've already given you 31 and 18. So B is going to be the same thing as this whole thing, Y. So if I were coloring it in, we would know that this whole thing is also the same, since it was told to us this is a parallelogram. So if all of that has to be the same thing as angle B that we're trying to find, then B degrees is going to be the 31 plus the 18. So that your B degrees would equal to 49. I'll go ahead and put that over here. 49 degrees. Take a minute to look at that closely. For, let's look at, where's C? I don't think I see C marked. See A. Oh, right here, 2C. 2C is not an angle. Notice it's on the outside. WX is 2C. Well, if 2C is equal to 22, then C is equal to 11. You divide by 2. That's just going to be an 11. That's not a degrees. It's just the segment measurement. Okay, so if we need to know what D is, and we know that the ones that are consecutive, notice how consecutive meaning as we name it X, Y, it sits next to in the naming of the whole parallelogram, those equal 180. Well, if we already found out that the 49 degrees was the missing, or the one we do know, well, then we can find the missing one by just subtracting. So 180 minus 49 is 131 degrees. So your angle D is 131 degrees. Okay, so now we're looking for angle A. Well, if angle A is this one right here, there's several things we've got to look at first in that, let's see, if this is 18, then the measure of this is 18 degrees, and if this is 1831, then this is 31 degrees, and we've got the measure, is it a degree? I think that may be a degree measure. Let's see. Oh, it is. Didn't show it. Sorry. This would be the degree measure, I didn't put degree, of just this little section right here. Well, again, if these two lines, WX and ZY, are parallel, this is the transversal that cuts through them. This angle, YXZ, is an alternate interior to WZX. So if this is 15 degrees, then A is 15 degrees. Again, if you need more help with this kind of deciphering all of these different values, A, B, C, and D, ask your teacher. That concludes 6-1.